I was enjoying the tunes and enjoying seeing your little fun facts. Pretty cool that Oscar drove his electric car for that large distance. So let's get started on the coding case. I know you all are probably dying to know how to code what the visualizations that we observed earlier. And so let's look at the notebook that has the coding portion. And if you haven't pip installed your requirements, make sure to do so. Otherwise, you won't be able to run a lot of these cells, starting from the first one. So make sure you do so before you get started on this. So run your first cell and then load your your data set. So this first part, again, we're just loading the packages that we will need here, and we will be using matplotlib and Seaborn for our visualizations. Okay, so PD, you're probably familiar with this already. So pandas read CSV is what the function that reads the CSV file here. So let's take a look. So the first thing is we're just taking the first 5 rows of the data frame from the energy consumption portion of it. Again, this is probably familiar, though something familiar that we saw a little bit earlier. And so yes, Lara, make sure that you install your requirements before you load the notebook. So anybody that has no module name something, it means that you are missing the requirements. Yeah, there you go, Julian. You could run that in your terminal, pip install our requirements. Okay, so the first 2 lines of code is just taking a look at the first few rows of your data frame. So again, this is something that you need to do every time you want to be able to see what you're dealing with. All right, so we are going to be pre-processing our data before we make our visualization. So remember, we talked about removing the missing values, shortening the description, removing any unnecessary columns that we don't really want to talk about or deal with, and splitting the year months column into year and months, and understanding the month 13th and remove it from the data set. So we're going to be going one by one. All right. First, we want to look at the data types. So remember, we originally in the analytical case, we look at the data types. And the way to do this is using this method called .dtypes. This is your data frame name. And then this is the .dtypes. Okay. So from there, you could see the different data types for each column. Okay, so remember, we wanted to know why the value is an object, right? So in order to do that, you should be able to look up quickly why that's the case. So a little trick here is to sort the values. So Jorge, we talked about the month 13 is the aggregate of all months from January through December. And that's not really one we want to look at here. So we'll look at it here again, but we went over a little bit in the analytical case. Okay, so once we sort the values, you could see here and then print them. You see here that you start from the numbers here, and then you see at the end that you have this not available text. And in this case, we know that we need to deal with this. We cannot have text with numerical values. All right, so the first thing is that we're using here is that replace. So this is a function associated with a data frame. So we're picking up the value column and then replacing every occurrence. So every time you see a not available, it's going to be replacing with MP none. So we're going to be replacing with missing value. In this case, missing value is just going to be ignored in most of the calculations. And then we are reassigning it to the original data frame. That's really what this code is doing. We can do that replace to the whole column, yes. If, let's say you, yeah, you can do it. But so anytime you think, do you think I could do this? The best solution is for you to, you could try. That's the easiest thing to do, right? You could also look up things. I like just trying. So you could just make a different or a new cell above or below, and then see what happens when you do that across. Okay. Now that we did the replaced it, right? So now we want to see how many of those columns, or sorry, rows have missing values versus actual number. Does that make sense? So here, from this electricity DF value column, how many of those are missing? So first, we're looking at is NA. So we're saying, is it missing or not? So what it's going to return here is going to be true or false. And then from there, you're counting each of those differences. So the resulting is false. There's 7,386 that have values, and then 830 that are missing. Near to 10%, yeah. It's pretty common to have a lot of missing values for whatever reason. Data collection is never perfect, or there's errors sometimes that just kind of happens depending on how you're collecting the data. There's always, if it's somebody's entering manually, which probably these data sets are not necessarily so, but they forgot, and then it's no longer recoverable. So now that we do this, we could just get rid of those rows that have missing values. Again, remember that we don't actually care about those entries that have these missing values, right? They're not really useful to us. So you could, I mean, it's a little bit, we're doing this step by step. So the question is, can we get rid of it, everything, and drop everything that has not available? You can, but the easiest thing is to actually convert it to NA, because you could use this drop NA. But you can use just drop and then specify. Whenever you see a code, more likely than not, there is going to be a way to do it differently. And we're showing you one way. So if you know a different way that you prefer, that is okay. The end result is what matters, not how you get there. Okay, so now we're just dropping the NA. So anything, now that we converted those to nuns, we could drop them from our data frame. And this is our new data frame now that doesn't have any of those missing values. Right now, the value is still an object, so we want to convert that to a float. So it still thinks that it's a text. So the float, this as type float, is going to convert everything to float now. So once we do the D types again, you could see that instead of object, now it's reading as float. Okay, any questions so far? So why float? Because it's, you could see here, it's a floating number. Okay, so far we have the D types. We have used D types to look at the data types, sort values to sort series, that replace to replace anything that you want really with something else. We could have replaced it with something else if we wanted to, but in our case, that's not really what we wanted. So for example, here, we could have used that replace, I don't know, NA, but that's not going to do anything. It's still going to be typed as text. So we have to apply this NA that, sorry, np.na. And then to determine how many of those are missing, we could use combination of isNA and value counts. So object is, generally speaking, either, there's a few scenarios why it will show objects. So it's either text or it's mixed values. Okay. So words. So str.replace works for strings only, and replace works with anything. So type objects, not always. Like I said, it could be mixed types, but pandas just interpret those as text, so strings. It will, as a result, it will treat it as strings, yes. All right, so the first, so let's look at the first example here using that replace, now that we have used it, and how we could take a look at how powerful this is. Because we could use a dictionary to replace everything in the data frame. So if we make a dictionary where you have the original value and then type in the replacement value, we could use that replace to change that. And we're going to use that to do the description change. Remember, we want to change it to these abbreviations. And so you're given this dictionary already. What a dictionary is. Okay, so dictionary is kind of like, think of the dictionary that you know. You have a key to look up something, and then the value that returns, right? So in a way that it's like a key value pair that you could use. And you could enter a lot of these key value pairs in a dictionary. Whereas like a list is just a lot of things in there, but they're not necessarily matching key values. Okay. So you're now given the dictionaries to replace it. So you don't have to type all of this. Somebody else typed it for you. So let's take a minute. I know that's not a lot of time, but to see if you could use this to change the description column for both the energy consumption and energy generated data frames. Okay, so let's take a minute and see if you could come up with the code. So Mike, you can replace it with anything else, except if you just use PEC, you will not have the sector information in there. Okay, so folks are moving on already. We haven't quite gotten there yet, so let's hold on for a second. Yeah, there you go. So we were replacing the original description column with this new column that it's replacing all this original description with the new one. And that's how you use that replace. So you see how this is pretty powerful when replacing multiple entries. And same thing for the generation data frame, we did the same using the data frame. So folks are already working on the next exercise here. So let's take another minute to see what you can do to replace it. So this time you didn't get the dictionary, so you have to do the dictionary first and then replace it. So somebody's asking, is the dictionary necessary? I mean, I'm not sure how you will be planning to change the value before, but I'm seeing a lot of answers here. Yeah, seeing some great answers here. All right, so here we're doing it in steps. I know some of you are probably going to ask, can we do it in one step? That is, you can. The strengths of doing it in step is that if something goes wrong, it makes it a little bit easier to debug your code to figure out where things went wrong. But here we are first determining the dictionary. So we're going from trillion BTU to trillion British thermal units, and then replacing the unit column with this new column that has those changes. Okay, is this clear so far? All right, getting some couple of clears. Clear as water. Yeah, there you go. People getting their code. I mean, if you reverse the key, for example, if this was reversed, it's probably going to give you an error the first time you run it, because it's going to say it doesn't know this, this doesn't exist. Okay, so let's move on to removing those columns that we don't care about. So remember, we had two columns, MSN and then column order, that we really have no use for. So we're going to drop them using that drop method. Okay, so the method, it's associated with this data frame, the pandas data frame. And then you could specify which columns to drop by saying columns equals, and then give a list of the columns that you don't want. And that is going to be replacing, and then we save it as the new data frame. So once we do those changes and we print, you could see here that we don't have those columns in there anymore. Okay. All right, so we've renamed things, we dropped columns, and now we are making new columns. So we want to split the year months column into year and months in two separate columns. So the main reason is it's not that you have to do this, and there's other ways to be able to manipulate your data without having to split the column. But once you split it, it just makes it a little bit easier to do some other analysis. And so this is a little bit of a preference for some folks. People prefer to keep it as one column, but here we're going to go ahead and split it into two. And we're going to take advantage the fact that we could convert it to strings and then slice the strings. So that once we convert this, so it's a number, but it's converted to string. And now we do that strips which is going to select the first three numbers. So now I know it says 0 to 4. And they're still being shown. Yeah, I feel like there's like some confusion about the changes that we made earlier. So remember, we were changing from trillion BTU to trillion British thermal units. So this is what we want to see. Okay, so the slicing, again, when you're slicing something, you could, you start with whatever your starting point is, and then to the point one above. So the 0 is inclusive, the 4 is exclusive. So it only goes to up to 4, not including 4. Does that make sense? I hope this is clear enough. So it goes 0, 1, 2, 3, and it stops. Okay, so by doing so, you could see here, now we have the year column. And that has only the first four digits. Then we could do the same for the electricity data frame. So which made a change for both data frames here. Okay, so now it's your turn to make the months column here. So I'll let you take a few minutes. So let's take 3 minutes to do this. See if you could come up how to replace, oh, sorry, how to make the new column that has only the year, or sorry, only the months. Okay, saying the wrong thing. Make the months column here. Oh, it's already done for you. Gotcha, sorry. Okay, so we'll move on then. Yeah, so you could do 4 to 6. You could certainly do so. Here, we're showing you negative slicing. So instead of doing from left to right, we're going count from right to left. So the -2, and then if you don't specify the end, by the way, so if you just have the column and nothing, it will go to the end. So what it's saying is take the last 2. So let's see here. It's counting -1, -2, starting from that number, or not that character, give me the rest of it. So now we end up with this months column that has, correct, Catherine, when you're doing negative slicing, it starts from -1, not 0. Yeah, 4 column also will work in this case. But again, so here it's very little, right? So it's not the end of the world to be counting, right? But what if you have like a really, really long string? You want the last couple of characters, right? Then you don't want to be, even here, for us, let's like for a second pretend that we want to pick just TOR, for example. That's all we want. You don't want to be counting from the top, right? That's a lot of counting. Yeah, exactly. So instead you could do -3 to the end. So there's definitely a place for this negative slicing. So it's good to know that you could use it. All right. So let's remove the 13, the month 13, right? Remember, this is like the total. So the values are the total of the whole year. So in order to see these trends, we don't actually want to see those 13 months. We just care about January through December. We don't care about the total. Okay, so we're getting there, so bear with me here. So right now, first, we're determining a filter. So we're picking all the entries that have 13 here first, and then we're gonna drop those columns that have 13. And the main reason you're doing that index is because here, when you do, so let's try this. Okay, so let's, okay, so if we run this, oh, right, sorry. I think the problem is like I already run this, so it's not gonna work here. Well, but if you run this before you run everything else, it's gonna return the data frame. And what you want to do is select the index and drop just those that have that particular index. Does that make sense? I hope that I didn't confuse you more than clarifying it. Okay. So now we drop this and we end up with this new data frame that you see here. It doesn't start at 1, but instead it starts at 24 because it dropped all the months that have 13. Is confused. Oh, you're confused about the index. Okay. So that index, it just picks the index or whatever data frame you have. So let's see what we have here. Do we still have energy? Yeah. Yeah, okay. So if we do the index, oops. See here, it's only picking the index here. You see, it starts from 24 to whatever at the end. It's only picking those. That's what that index does. Right? So when you're dropping based on the index. It will drop the whole row. Yes. Okay. So, right, I didn't realize that was the confusion. So yes, you're dropping based on the index, but you're going to be dropping the whole row. And that's why you don't see 1 through 23 here. Okay, so we're doing the same thing for the generation, the energy generation data. Yeah, you could certainly do it differently. Again, we're masking using the equals 13, but you could certainly pick everything that is not 13. The main reason, well, again, every time you do something more likely than not, there's always a different way of doing it, right? And that is okay. Coding is flexible in that sense. Okay. Let's move on here. All right, so identifying the relationship between energy consumption and generation. So now we are actually trying to move towards plotting things, right? But we still need to, we don't want to plot the whole data frame. Rather, we are going to be focusing on particular sector. So for the consumption, we're picking just the electric power sector, and then the nuclear electric power for the generation, right? So this is all what it's doing. So you're subsetting. So out of those entries that have this value, keep those. That's what this code is doing. So if this column, the entry in this column matches this entry, it will give you, this particular thing will be like essentially, sorry. This particular part is only gonna give you yes or no. Okay. Why in the column MM isn't, I'm not sure if I'm following. We got rid of the 13 already. Okay. So somebody's answering that, so awesome. And okay, so once, if it matches that, it's going to be picked and returned. All right, and then we're getting rid of, again, the other columns that we don't really care for this particular plot. And we are gonna end up with just the year months column and the value. Okay, so we actually do consume ahead. Do I know that the right thing? I might not have the right thing. Well, after doing this, it should have only these two columns. Okay. I don't know why it's doing this here. I run it differently, so it might not give me the same thing. But if you run it in order, it should be able to give you what we were expecting. Yeah, there you go. So Gloria shared it here. Okay, so now we're doing a comparison. These two values are living in two different data frames right now, right? So what we need to be able to combine it. And we're going to be using pd.merge function. So the pd.merge, you have to select a common key to be able to merge it. Okay, so we'll go one step at a time here for a second. Okay, so we are now taking the first column, the first data frame, so the consume energy and then the generate data frame, so these two, and then you're going to be merging on the year months column. And once you do that, because both of those data frames have the column named value, it's going to automatically insert this underscore X and underscore Y. Okay, and you could change that by specifying what it's going to look, how it's going to look like here. So for this other one, we're going to do the same. So if we run this part here, it's going to look something like this. But instead, we decided that we are going to insert underscore consume and underscore generate. Okay, so now it's going to be looking like this. And the default is inner join essentially. So we'll talk about joins in a little bit. All right, so now that we have the data set that we want to plot, we could finally plot this. And we are going to be using matplotlib. I know I mentioned it earlier. This case, and matplotlib is very flexible in how you could plot everything. So you could specify a lot of things. So for here, the first line is we're going to be making a scatter plot. Right, so if you do specify a scatter plot, you have X and Y axis. So you have to specify that. So the the X axis is going to be the value generated column. And then the Y axis is going to be the value consumed. If you take just this line and run it, it will make a plot. It's just not going to be showing this pretty axis. So it's always a good practice to fix those titles and axis. And in order to do that, so we now add in the title. So you see here, the plt.title is, so this is something that when you plot it, it runs, it kind of drives me nuts. You could actually suppress it by doing this. It's like specification that matplotlib prints out when you're running it on a notebook. So if you don't want to see that, just add a semicolon at the end of your plot. But now I screwed up the plot, of course, because I think it's overwritten. You could also do PLT show. You don't really need to do that here because Jupyter Notebook kind of automatically does it for you. Okay, so the title is specified by adding the line plt.title. The x-axis title is label is changed by doing the plt.x label, and similarly, y-axis is that y label. Okay. It just suppresses the output. Here, if I remove it, you see this line here. You could get rid of it by adding the semicolon. You don't have to. It's not important for this particular purpose. Okay. Yeah, I know the scatter plot, I screwed up one because of, I rerun it. I shouldn't have done that. if you run it, it should look like the way you show it. Yes, that's exactly what it should look like. Gabriel, if anybody's seen what Gabriel is seeing, that is the correct output. All right, so somebody mentioned what is the default. So PD.merge on pandas will join things. The default is inner join. Okay, so the format is, so let's see here. PD.merge left, which would specify, let's say for a second here, this is the left data frame, and right is this data frame here. And you want to merge, this is the common key, so you want to be merging on this number plate. And then if you specify how, so how are you going to be merging? If you specify left, you're going to be taking the keys from the left data frame and seeing if there's a match on the right data frame and return that. Okay. Yeah, there you go. So that those visualizations always help when you're trying to decide how to merge things. On the other hand, the right joint, you could do that by specifying right. And instead of taking the left key, it's going to take the right key and seeing where there's a match and return that. Okay. So you could see here that when it doesn't find a match, it will add it, but then it will introduce these nones. Okay, if you can't find it, it's just going to be added as missing value. Okay, so most of the time we use inner merge, and that's what default is. And that's why we didn't specify it there. Got a little lost. Okay, so let's go over this again. So we have these two data frames. We call this L and this other one R. Okay. When we specify left join, okay, so this is a left join, you could see here that we're keeping all these this column from the left and adding all the value from the left still. So these are intact, this part is intact, okay? But now you could see here that the only common one is this particular one, right? You see it here? These other two do not exist in the L data frame. So it's gonna add it here, but because it doesn't find anything, it's just gonna introduce missing values. Is that more helpful? Let's see. Okay, somebody says yes. Okay. All right, so similar, this is just reverse, okay? And inner, again, remember there was only the one common one, so it's going to return only one row. Full join is a different type. It's essentially going to be adding everything. So now we have 3 columns as always, but it's going to keep all the entries. So now instead of, so we started with 3 and 3, we end up with 5. I don't think you could do that, but you could look at the pandas merge for specifying what kind of joints you could do. Okay. Oh, and for full joints, you specify outer here instead of full. I know it might be a little confusing since we call these full joints. Okay. Oops, I'm showing you there. Okay, so copy the code from the previous cell and paste it below. Then modify it to make a scatter plot of PC commercial sector and ENG nuclear and electric power this time. Yes, you could join on multiple keys, but we won't get to that right now. We're specifying just one key right now. Again, when you have any thoughts, can I do this? The best solution is try it, see what happens. Okay, that's like the easiest thing to do is just try, see what happens. Oh, somebody's been working on the code already for this, so. Okay, so I know this is not looking right, but we have all this code to change, and now from here to here, change it so that we're plotting. Oops. PC commercial sector and ENG nuclear electric power power. Yeah, I think all of you are. And somebody dropped the pandas merge documentation. Awesome. Yeah, so people are getting it. Okay, let me turn on the light here for a second. All right, so again, we're doing the same exact thing as before, but instead of yeah, there you go. Instead, we're picking the PC commercial sector. So that's reflected here, and the ENG nuclear electric. So that's reflected here. And the rest is the same. Of course, you're fixing the labels here too, right? And voila. Yeah, a lot of you are definitely, it should look something like this. If it doesn't, you probably picked the wrong column. Somebody got an empty plot. I'm not sure what you ran there. Okay. I think you are getting it. So so we're not going to get into a lot of the nitty-gritty details of how you can manipulate everything, but yes, you can change the size, the color, this like how the grid appears. Yeah, so share the code here. I'll share in chat.
Miko,
Yeah.
they are going to solve tomorrow the workshop. Then,
Oh, gotcha.
Then the idea is you walk through the concepts and exercise, but tomorrow they will be working with TAs to actually code the exercise.
Gotcha. Okay. Let's move on then for a second. Okay, the trends over time. So this plot is going to be similar as before. We're going to be subsetting. So again, we're only picking those, oops, I keep doing this. Those that are matching the PC electric power sector. Okay, so now we're copying it. And so the reason we copy things a lot of time is because we sometimes make a change and we want to keep the original. So if we do that copy, this one that we made before, it's not going to be changed. Okay, so we're making a copy of it. And now that we plot it, oops, we plot it using plt.plot, and the default is a line plot here. So if we pick the value, it's going to be plotting the line plot. Okay, I hope that's clear. So line plot, that's how you do line plots. It's plt plot and then specify it. All right, how are we doing on time? I think we're okay on time. So, all right, so this saying, okay, so this is nice, but you could see here that the x-axis is not really telling us anything, right? It doesn't seem right. And okay, so here we go. The main reason is you could see here the year, month, date, or sorry, year, months column. It's still a string, right? So what it's plotting here is that string altogether. So it thinks that it's plotting this number, right? So we need to convert that to date. So to do that, we use this PD to date time. Okay. The PD to date time, you could specify which column you want to convert, and then specify the format. Okay, so now with this, what it's saying is it has the form of year, the four-digit year, so that's why it's capital Y instead of lowercase y, and then followed by a month and nothing else. Okay, that's the format that it's following. And so now when you print this, you could see that it, well, okay, we made a new column here. So we specify here that a new date column where you actually have the date format. So if it's, you could look up all of these things here, but it will look something like this. If you want year slash like that. So capital Y is 4 digits instead of, so you know how year sometimes 2 digits? So if it's 2 digits, you will use the lowercase. Okay. Again, when in doubt, when you don't understand something, the best thing to do is to look up the documentation of that particular function. Okay. All right. So now we have this new column, the date, and because it doesn't have the date, the day, it will automatically insert 01. It just doesn't know what to do with it. So that's the default. So now if you did that D types, it's going to be, it should be printing date time type. Okay, so now we have this date time type. Okay. All right. So now we can make this plot better. So the first line here, we're actually going to be making this a little bigger. And go ahead and play around with these numbers and see how it will look. And so that you could kind of see how it's going to be printed. The default here, you could see it's a little bit small. It may not be the best if you have long time frames like here, right? Because it's going to be like squished together. So we're making it longer and a little shorter. Okay, and now we plot in the date column and then the value column. Okay. Again, fixing the title, the x-axis label, the y-axis label. And voila, now we have this beautiful column, plot that has the year, months, so the date, and then the energy consumption values. I know it's a lot to take. I know we've gone over a lot of things today. Don't stress about it if you didn't get the first time around. I guarantee you that with practice, you will get this. It's like when somebody tells you, when you're learning something new, it's always going to take some time. For if you're some type of a genius, maybe you can, but for most of us, we just need to practice. When you started riding a bike, you probably didn't get it the first time around, right? Like you have to get to that point, make those baby steps until you got to the point to be able to ride a bike. Same thing with coding, you just have to practice. Awesome. Okay, so remember, we are interested in looking at the monthly percent difference, right? So what's the change from the previous month to the next month? That's what we are trying to look at here. And in order to do that, we're using this %, PCT change. And what this does is, let me open this up so maybe you could see what it happens. So this is the original column, right? If you print this, this is how it looks like. And when we do that PCT change, it will calculate the difference, the % difference from the previous month. And that's why you are missing the first line here, because you can't really look up the difference from the previous month. Okay. And the default is for PCT change is to look up the previous one. If you want to do annual, you'll have to specify 12. step here. But again, look up the documentation for this function, and you should be able to find out how to do it. Okay. I'm also trying to give you like the tools that you can use when you move on outside of this class setting. So that's why I don't give you the answers immediately. I provide you the tools that you can use to be able to figure out yourself. And yes, Google is our friend. We change things like the Google things all the time at work. I do it all the time. Yes, Carlos, we use the first one because what it's doing is, I mean, you could manually calculate this. If you take this, subtract this from here, and divide it by this, you're gonna get that number, the first number. But because the first number, you don't have anything to subtract from, you don't get a number. Okay, so that's what it's doing. And again, we are using that percent change to plot this using the same plot, the line plot, and specifying the date and the value that is now the percent change. Okay. Okay, so I know I guess you're gonna go over this with your workshop tomorrow, but let's think about this for a second. So you're going to be repeating the steps above to change, or so to make a new plot. Okay, and let's see. So for the brevity of time, this is what it will look like. I'm not gonna share the code this time. And same with the percent change. You're going to be doing that same thing, except with a different the different column, or sorry, entry. All right, let's move on a little bit to do a little bit more polished look using Seaborn. So Seaborn is another plotting package from Python that you could use, and uses matplotlib under the hood. So a lot of the specifications will be looking similar, but it's still, because it's different, the way you change things will look a little bit different as well. I know I'm not making any sense right now, but it'll make sense once you start seeing it. It's similar to ggplot2, yes. Not quite, but it does look, the output looks a little bit more polished like the ggplot2. For those of you who are familiar with R. If you don't know what I'm talking about, don't worry about it. All right, so we are looking at heat maps now. Remember, we were looking at it earlier, so let's go back if you could see here. These heat maps, okay? That's what we want to make. And Seaborn conveniently has a function called heat map. Okay, and it is going to make that beautiful plot for us without much coding. But before we get to it, we need to pivot our table. So for those of you who are Excel experts, probably are super familiar with pivot tables. But But if you're not, do not get scared about pivoting plots. You just have to get used to how to do it, okay? So again, this first line, we're just subsetting, picking the ENG nuclear electric power. And to pivot the table, we use this pivot table from pandas, okay? And you have to specify the data. So here, we're specifying this data frame that is the subset, and the index. So for those of you who are asking, why did we make those two columns that before for months and year? This is where it's gonna come in handy. So here we specify that we want the index to be the month column. And then the columns, each column to be the year, okay? And then the values are going to be calculated from, or taken from the values column. And then the end result is going to look something like this. Okay, so you have the months as your index, and then the years as your columns, as you specify here, right? So index here, columns. Does that make sense? I mean, I hope this is not intimidating. The code is pretty simple. So you just have to specify how you wanted it to look once you pivot it. All right, so now we have this pivoted table. We could use the CVOR, the SNS is the abbreviation for CVOR, heat map. Again, we could, remember I told you that it uses matplotlib under the hood, and that's why we could use some of the specifications from matplotlib along with CVOR to change things. So we are making this bigger using the matplotlib command function that we used before. And then now we're plotting the CVOR heat map. So you're using the pivoted table, and then here the C map, so the color map, we're specifying cool to warm. So that's blue to red, essentially is what it's saying. So you could change this. And again, go ahead and look at this CVOR specification for colors, and you will find you could play around with a lot of different color schemes, and you go ahead and have fun with it and see how it looks every time. Okay, so now we have this beautiful heat map that has the years as the x-axis, the months as the y-axis, and then all the values plotted as a color scheme. Yeah, like you could make a lot of things weird if you don't specify it correctly. Yeah, there you go. Some of you are choosing different color schemes. Like I said, have fun with it, see how it looks. Okay, box plot. This is one of the really, really powerful things about CVOR. I think and I know some of you are a fan of violin plot. CVOR also does have a way to plot violin plots, but right now I'm showing you how to plot box plots. Okay, so with box plots, you have to specify what you're going to use on the x-axis. So that's your labels, right? So your categories. and then your data points on Y, and from which data set. Okay, and again, matplotlib is coming back here because we want to change so these labels. If we get rid of this, the labels are going to be horizontal. And so by rotating in 90 degrees, they print like this. And again, this is the default matplotlib color scheme. You can't change any of these. Yeah, there you go. So change the rotation, see how it looks as well. Sometimes you do have to rotate it at certain angles for it to read, to make it more readable, depending on how you want it to bear. Or for example, for some reason you're making a report that has a very tight space for a plot, you may want to change the labels a little bit, right? So C-varm plots are a little bit finicky when it comes to matplotlib specifications. So you could see here, we're using, instead of doing the PLT that figure to specify the size, you could do it, but it may not do what you wanted it to do. So instead, we are specifying the two things that come out of the PLT subplots, okay? And within that, we're specifying how big we want the plot to be. So the syntax is a little bit different to specify, but it's similar enough that you should be able to figure it out with practice, okay? So do not worry if you are confused right now. It will come with practice. C-varm box plot, that's the command for a box plot. And then, again, same thing. We're specifying the axis, oh sorry, the x-axis, the y-axis, where the data is coming from. And this is the key here. You're specifying this AX to make these changes happen. Okay, and now the whole thing is bigger. Again, play around with this, read these specifications, documentation, and you should be able to make different colors, different plots, all you want to dream of. I think the exercise 4, I am going to only talk about in terms of SNS strip plot. So you could specify a different type of plot. C-varm, again, you could even make violin plots. I'm reading the GIFs that you're sharing here. You could specify different plots by this simple changing command, okay? And see how it looks. So a lot of you have already tried it and see what happens, but you're also going to be going over that in your workshop. All right, so I know we went over a lot of things. The fig specify the figure area, essentially. Okay. So to cap this, so we actually covered a lot of different pandas data frame methods here and functions. So go over them again, read the documentations, like again, like you even getting the links here, just click on them, read over, see what else you could specify and find how you could use it. Like box plot, you know, you could change colors, you could change, see, like there's so many things you could specify here. Take a look and see if you could play around with this, how it looks, okay? And I hope this was helpful. I'm happy to share my time with you, and let me know if you have any questions. It was a pleasure spending my evening here. All right, somebody speaks Japanese also. All right, thank you all.